Doodly neighborinos. Today we're looking at factorizing. Now, I've just got the textbook up, and yes, there are four main methods of factorizing. We've got taking out the highest common factors, so the biggest number or pronumeral that goes into everything that you're trying to factorize. Difference of two squares, you know, when we were expanding our a plus b, a minus b, and it became a squared take b squared, well, it's going the opposite way from that. It's usually fairly easy to recognize. Sometimes you'll have some surds. They're not absurd. Quadratics. Now, there are two different types of quadratics. The nice easy ones where you don't have a coefficient in front of the x squared term. And then the harder ones where you do, and then we'll learn a method for that. We did those fairly extensively last year, so hopefully it'll come back to you pretty quickly. Quadratics can also always be, well, they can be solved using the quadratic formula, factorise using the quadratic formula, and then just chucking it into A. You'll remember when we get there. And grouping. And grouping is a very handy thing to do because it makes some things that look impossible possible. Ew. So today's exercise is going to be split up into 4 different videos. Let's have a look at factorizing by taking out the highest common factor, which is the first thing that you should always try and do. It often makes harder stuff much easier. So let's have a look. In this first one, what's the biggest thing that goes into 4x cubed plus 3x squared? No, it's not 1. It's the x squared, because x squared does go into x cubed, because don't forget x cubed is x times x times x, so it's x squared times x, so we can take it out. No. Okay. So if we have a look at A, and we've got our 4x cubed plus 3x squared. Oh, that's weird. I don't know why that's doing that. I really hope it doesn't continue to do that. That's annoying. I've already told you, x squared is the biggest thing that goes into both. There's no numbers that go into both 4 and 3. X squared. So we've got 4x cubed. We need to take x squared out of it. Now, you could write this step of working out, or 4x cubed over x squared. You don't need to. 3x squared over x squared. You can see x cubed, x squared. No. What's 3 take 2? It's 1. X squared, and we get x squared out of 4x plus 3. If we now have a look at B, and we've got, wow, that looks intriguing, 9a squared b cubed minus 15b cubed. Now, let's have a look at our numbers first. What goes into both 9 and 15? Yes, you're correct, hopefully, it's 3. A squared b cubed and b cubed. Well, b cubed appears in both of those, so I'm going to take that out too. And yes, we're going to do this one in 2 steps. You don't have to, you'll probably visualize this. So we've got 9a squared b cubed over 3b cubed minus 15b cubed over 3b cubed. You do not have to do this step. I would actively encourage you not to. Anyway, we've got 3b cubed outside of. Let's have a look. Well, 9 and 3. 9 divided by 3 is 3. 3 divided by 3 is 1. Do we normally bother writing that one? No, we don't. A squared, there's nothing to cancel out there. B cubed and b cubed. Hooray, they're the same. We could write 1 and 1, but why would we bother? 15 and 3. 3 goes into 15 5 times. 3 goes into 3 1 time. B cubed and b cubed, same diff. So we end up with 3b cubed outside of 3a squared minus 5. It's not rocket science. What is rocket science is figuring out how to stop the video.